So I want to graph this cube root function. Here's your h and k, just like a square root. Now, we're going to fill in this table in a second, but we're first going to talk about the shift, stretch, flip using your h and k. So, for this particular problem, you got h and k right there. All right. This one right here tells us our h, which does the opposite of 1, which would be left 1. So we are going to go left 1. And then the negative 3 tells us our up and down, or k, which means we're going to go down 3. Now, what that means will make more sense later on, but the graph of a cubic x, a basically cubic x, will be shifted left 1 and down 3. All right, does this have a stretch or a shrink? Well, the number in front's a 2, positive 2, so it is going to be, if you multiply something by positive 2, that makes it bigger. So this one's going to have a stretch. Now, by what factor is it going to stretch? It's by a factor of your a value, so a factor of 2. It's going to stretch by a factor of 2. Now, will this one flip? Well, is that positive or negative? It's positive, so the flip is a no. So that right there tells us some key features of the graph, which for graphing these, those key features are actually really important. Because we're not going to make them, we're going to be a little bit more quicker at sketching these. Anyways, our domain. So what values can you put into a cube root? Well, you could put all real numbers. There's no restrictions. There's no imaginaries when it comes to cube roots. So since there's no imaginaries, you can put anywhere from negative infinity to positive infinity into this table. So since I can put negatives and positives, what I want to do is I want to right smack in the middle, I want to put hk. I want to put hk smack in the middle. And if we looked at this carefully, isn't h negative 1 and k negative 3? So h is negative 1 and k is negative 3. That's the smack middle of my table, so I can graph this. Now if you think of cube roots, you have to think, okay, I'm going to go 1 to the right and 1 to the left. So 1 to the right of negative 1, if you think about that, is going to be 0. 1 to the left would be negative 2. Again, I added 1 this way and I subtracted 1 this way. Can you plug those values in? Yes, you can. If you simply plug in 0, you can plug in 0, but there's a shortcut. If you think back to square roots, wasn't the a value how much this value changed by? So when you went to the right, didn't you technically just go make it 2 bigger? If you think back to the last type of problems, when you go to the right, that negative 3 is going to be 2 bigger, so it's going to be negative 1. Because the a value is how much this is going to grow by. Where in the opposite direction, it's going to shrink by 2. So on the other side, it's going to be a negative 5. Now, I might have confused you right there. Why did you add 2 here and subtract 2? It's your a value. If you don't like that shortcut, can you simply plug 0 in and crunch the numbers? Can you simply plug in negative 2 and crunch the numbers? You'll see they work. So let's plot the dots we have so far. Let's plot hk. hk is negative 1, negative 3. There's hk right there. Next, we're going to plot 0, negative 1. And we're going to plot negative 2, negative 5. You're starting to see the cube root graph show its face, show itself. Now the question is, how do you get these other values? Well, when we sketch in this class, we're actually not going to care too much about these, but I'm going to do it just to kind of show you. But really, all you need is these values right here. Okay, so, but how do you find these? Well, don't you want to use 8 for your next cube root? So 8 away from this is kind of a little tricky, but 8 away from negative 1 would be 7. And 8 below would be negative 9. Because the cube root of 8 is 2. That's why I chose a span of 8. Again, normally you won't have to make this table, and I'll show you that at the end. If you plug in 7 over here, yeah, you could. Could you also plug in negative 9? Yeah, you could. But what I hope you understand is all you're doing is you're going to add 2 once again. So now it's going to be negative 1 plus 2 is 1. And on the other side, you're going to subtract 2 once again. It's kind of a pattern. As you take one cube root, so you use nice cube roots, you just are adding 2 every time to the right and subtracting 2 every time to the left. It's just kind of a nice little pattern. So 7, 1 would be right there, and negative 9, negative 2 would be out here. And if I sketch this, there's my cube root. Bam. Now, quickly, is it increasing or decreasing? Well, can you see your values? If this is a roller coaster, you're just going uphill, which your values are also getting bigger as you go along this. So for this one, it looks like we are increasing. And let me just summarize everything. Summarize everything. Do we need this table for sketching cube roots? No. Let me show you the very quick, easy way. I kind of did this table to show you, and maybe confused you. Here's how you sketch cube roots. Negative 1, negative 3. Got it? Your a value is 2. So over 1 up 2, over 1 down 2. Sketch. Done. You don't even need the table. But I wanted to show you how the table works. Again, negative 1, negative 3. That's the middle. Over 1 up a, over 1 down a. Sketch the curve. We are done. Which makes sense. Didn't we go over 1, down 3? Isn't there a stretch of a factor of 2? And did we not flip it? All that makes more sense now as well.